Hello everyone, and welcome to today's lesson. So we're going to take a look at section 4.5, factoring quadratics, and some special cases. So first thing we're going to do to warm up is we're going to evaluate each perfect square. So the square root of 1 is going to be our positive 1. Square root of 4 is going to be positive 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. And lastly, the square root of 100 is 10. So the reason we're doing this is that in case you see these numbers in some questions in a little bit, we're going to learn some easier methods that we can do, or some shortcuts perhaps, to save ourselves a bit of time when we're factoring. So the first case we're going to look at is the difference of squares. So a polynomial that has the form a squared minus b squared, you can see there are two terms here. Okay, this is the difference of squares and can be factored as a squared minus b squared, and that's going to equal to a plus b, a minus b. So first thing we're going to do is check that there is a minus sign between the two terms. It can only be the minus sign signifying there's a difference. Next, we're going to check that there are two perfect squares, and if so, we can utilize this nice shortcut of a plus b, a minus b. So what we're going to do here is factor each expression. So our first step is going to check, do we have a difference between those two terms? We can clearly see that there is that minus sign, so yes, that checks out. So now we're going to take a look to see if in fact this is a perfect square and this is a perfect square. So what we do to do that is we take the square root of this first term. When we do that, we get a nice value of x, and we take a square root of the second term. So the square root of 64 is equal to 8. Since these can both be square rooted, they are perfect squares, so we can utilize our square rooted values here as a nice shortcut that we could write this as x plus 8, x minus 8. And what you can do to remember this is that notice how we have this plus and minus. Because of that, that's why the x terms in the middle here disappear, because of these opposite signs. So next we're going to take a look at is 49x squared minus 100. So we can see we have two terms. And the first thing you always ask yourself, do you have a GCF here? With 49 and 100, we do not, so we cannot take anything out. Next we're going to take a look to see if there is a difference. And we can see, in fact, yes, there is. So we can check off this. The next thing we're going to do, let's see if now both of these two terms are perfect squares. So we're going to take the square root of 49x squared, and that is equal to the square root of 49 is 7. The square root of x squared is just x. So far so good. Now let's take the square root of 100, and that's going to be a value of 10. So since these can both be square rooted, they are perfect squares, it has the difference. So this is our difference of squares that we can write as 7x plus 10 and our 7x minus 10. If you were to expand this by using FOIL, you would get this exact same answer here. Let's take a look at the next example. We have 81x to the 4 minus 25y squared. So again, do we have a GCF from this? 81 and 25, we cannot factor out a number, and x and y, since they're different variables, we cannot. So we can see there are two terms. Do we have that difference? We can see that negative. Yes, we do. So the next thing we're going to do is see if we have two perfect squares now. So we're going to take the square root of 81x to the 4, and this is going to be the square root of 81, which is 9, and the square root of x to the 4 is x squared. We're then going to take the square root of 25y squared, and that's going to give us a value of square root of 25 is 5. Square root of y squared is simply just y. So since we can take the square root of both of these are both perfect squares, and we can write, using these square rooted factors here, of 9x squared plus 5y, and our other bracket of 9x squared minus 5y. So let's take a look at the last one here. Do we have a GCF? We do not. Do we have a difference between these two? Well, we can see here that we actually do not have a difference. Okay, since we do not have that difference, I mean, if we were to keep going, you can take the square root of x squared, which is equal to just x, and you can take the square root of 9, which is simply 3. But again, because this is not a difference of these squares, what we can say is actually that this cannot be factored. And we leave our answer exactly how it is. So let's take a look at this next example. So we're going to look at perfect square trinomials. So what we're going to do first is factor the following expression using our techniques that we already know. Okay, so first off, is there a GCF from this? We always ask ourselves that question. So 25x squared minus 40x plus 16. So we can see here that no, there is not. So I'm going to utilize the slide and divide method because we have this a value that is not equal to 1. So we're going to slide this over here. 25 times 16 is going to give us a value of, since that slid over, we're going to get x squared minus 40x, and that's going to be plus 400. We're going to utilize our M strategy so that we have two numbers that multiply to equal a big number here of 400 and add to equal negative 40. So you'll notice compared to other questions, these are pretty large numbers. Okay, so again, you can always start with 1 and 400. Clearly those don't add to negative 40. You could also do negative 1 and negative 400. Those also don't work. 2 and 200, those also don't. 2 and negative 200, and you can just keep going. So this might be a little bit time consuming for you. But if you were eventually to get to the proper values, you would come to, we have negative 20 times negative 20, that equals 400, and negative 20 plus negative 20 is equal to negative 40. Because this is we turn this into a simple trinomial, we can write this as x minus 20, x minus 20. We did the slide, so now we have to do the divide. We're going to divide these by the number we slid over, which was 25. And we can reduce both of these fractions here. If we divide this numerator by 5 and this by 5, and this numerator by 5 and this numerator by 5, that's going to give us x minus 4 over 5 and x minus 4 over 5. Since this is all that we can simplify this fraction here, we're going to take this 5 and we're going to move this to the front of the x. We're going to take this 5 and move it up here. I've run out of room, so you're going to get 5x minus 4, 5x minus 4, and because you have that same bracket twice, we're going to write this as 5x minus 4 squared. So you can see this was quite the process to get this final answer here of this 5x minus 4. So what we can do is we can utilize this strategy here, that if we have an equation that is the form a squared plus 2ab, which is the square root of a and the square root of b, plus b squared, we can use a short form of a plus b squared. So if the middle term, though, is a negative and it follows the same format, we can simply just write a minus b squared. So the first one to do is check to see that a and c are perfect squares. We're then going to check if the middle term is 2ab, and if so, it meets these conditions, we can rewrite the equation as two factors of the perfect squares. Okay, so let's take a look at our examples here. So actually, we're going to jump right to this example of what we did this incredibly long and complicated way. So first thing you can see, or try to recognize, is that 25x squared could be square rooted, and 16 could also be square rooted nicely. So again, you ask yourself the question, do we have a GCF? No, we do not. But I've noticed that this could be square rooted and this could be square rooted. So let's just verify that. So we're going to take the square root of 25x squared, and that's going to be 5x. And then we're going to take the square root of 16, which is 4. So far, so good. So the second thing we have to do is we're going to see if we take 2 multiplied by this 5x, which is our A, multiplied by the 4, which is the B, and we're going to see that this is equal to 40x. So does that equal to, you can see from our equation here, this middle term? Yes, it does. So we can utilize our nice shortcut that we can write this equal to 5x. Since this is a minus sign, that is what we're going to put between this other factor, the square root of 4, and we do 5x minus 4 squared. So you can see this is much simpler of these perfect squares compared to doing it this long way of the slide and divide or decomposition. So let's take a look at this next one here. So we have 4x squared minus 12x plus 9. Do we have a GCF? No, we do not. Okay, always ask yourself that question. So what we're going to do, I've noticed here that this can be square rooted nicely, and a positive 9 can also be square rooted nicely. So we're going to see if these are both perfect squares. The square root of 4x squared is 2x, and the square root of 9 is equal to 3. Okay, so far so good. So let's see if multiplying 2 by these two terms, when you do that, 2 times 2x times 3 is equal to 12x. Since that is this middle term here, that is excellent, and we can utilize our nice shortcut. So we're going to have 2x. Again, this is the minus sign in the middle. This is going to be 2x minus 3 squared. Okay, this middle sign goes directly where it is. Okay, so same thing with this. So this GCF in this case is also a no. Okay, 4x squared plus 12x plus 9. But again, I've noticed, I know it's the same one as this example A, but the only difference is this positive. But what we do is go through the same process. You can notice that 4x squared could be square rooted nicely into 2x, and 9 can be square rooted nicely into 3. So now we're just going to check again. Does 2 multiply by that square root? And this one, again, gives us 12x. Oh, and sorry about that. I made a small mistake over here. This is actually 12x, which again is that middle term. Same thing here. This is 12x, which is the middle term. So we can write this one as the nice shortcut of 2x. Now, since the sign in front of this middle is a positive, we're going to write the positive and then the other factor, and that's going to be 2x plus 3. So that just comes down just like that. Okay, so let's say you see an example that looks like this perhaps. Okay, you can see these are huge numbers. If you were to do decomposition or slide and divide, it's going to get messy. But always ask yourself that question, do we have a GCF here? So unfortunately we don't. Okay, but you can recognize that 81x squared, we can take the square root nicely. And 64, you can also take the square root nicely. Okay, so 81x squared is equal to 9x. You take the square root of 64, and that's simply equal to 8. So far, so good. So now we're going to check to look to see if 2 multiplied by 9x multiplied by 8, when you do this, we're going to get 144x. Since that is our middle term, we can now utilize our excellent shortcut. So our first term is 9x. It is a positive sign in the middle here, so we're going to do plus, and then the other term, which is 8, and we're going to square that. So here's how we can use that perfect square trinomial method. So that concludes our lesson for today. Thank you all for watching.